Welcome to video 6 of the Search for a Better Health series. In this video, we're going to be looking at antibiotics, the role that they play in managing the disease, and then we're going to quickly discuss antibiotic resistance, how that might come about, and then, in fact, you're going to complete a research task to explore that idea further. When we talk about antibiotics, we're in fact talking about chemicals that are capable of destroying, inhibiting, or inhibiting the growth of bacteria that cause disease. They, in fact, target bacteria without destroying the host and are not at all effective against viruses. And this is a common misconception amongst society. Alexander Fleming discovered the first antibiotic penicillin in 1928. Howard Florey and Ernst Chan purified penicillin, which was available for medical use in 1941. There are two types of antibiotics which can be prescribed by a medical professional, and the first are broad spectrum antibiotics, and they act on a wide range of bacteria. They're used when the identity of bacteria causing the infection is not in fact known, and some examples are sulfonamides. And then we have narrow spectrum antibiotics, which act on only one or two types of bacteria. Obviously, when the bacteria or the identity of that bacteria is known, it enables doctors to provide specific antibiotics, and that's where we see things like penicillin being prescribed. The way or the mode of action, the way in which antibiotics work, so they accumulate in the cells of bacteria, which prevent them from forming a new cell wall when they are dividing. They destroy the cell membrane, thus effectively destroying the bacteria, or they can interfere with protein synthesis so the bacteria are unable to make essential compounds, resulting in the death of a cell. So, any one of these three is a possible mode of action depending on the specific type of antibiotic. How does resistance occur? So, widespread and incorrect usage can lead to the evolution of resistant strains of bacteria. So, by continually exposing the populations of bacteria to antibiotics, we increase the opportunity for resistant bacteria to survive and reproduce. And I guess one of the most common bits of information given to society is to ensure that the full course of antibiotics is completed. So that means that it's more likely to destroy any resistant bacteria which might be inside that host. So there are three ways in which bacteria might in fact develop resistance. So some bacteria have evolved an enzyme that destroys the ring-shaped molecule in penicillin. They may have a complex outer membrane with reduced permeability, so the antibiotic is not able to penetrate that cell. Or they might have modified penicillin binding sites, meaning penicillin can no longer attach to the bacterial binding site, which cannot affect reproduction or production of any kind of proteins. So this concludes video 6. Make sure you're in class to complete the activities and tune in for video 7.